Okay, so yesterday we talked about, we gave a bit of an introduction to how AnyLogic relates to this thing called Java, this cross-platform programming language that runs on PCs, Macs, Linux, what have you, and underpins the AnyLogic system. It's not projecting. We also talked about how AnyLogic handles Java in the form of actually outputting Java, so it turns your model into Java. Bits of your model are already in Java. You've already learned that, for better or for worse. And then it turns the whole of your model into Java, and then it renders it into a form called bytecode that it can actually run. Now, a lot of that is details, but those tools that Winchell and Priesri presented today, the tools that automatically record all the runs of your model, record the parameter assumptions associated with those runs, the screenshots of them, all those are made possible by the fact that it's running on top of Java. Okay, so it does afford us kind of access to an ecosystem, as it were, associated with Java that can be very useful, a whole set of tools that otherwise would be unavailable to us. So I'm just going to get this set up, and now we're in good shape. Okay, so yesterday we further went on to talk about these things called expressions, which are basically Java's version of formulas. They calculate a value. The job in life is to calculate a value, and we use them all throughout our Java, all throughout our models. We use them when we put things into the statistics associated with the model. So you may recall that associated with the models that we build, we can define these statistics. And so, for example, we could go and we could look at this open population model we created yesterday, and we could go down and look at the population here. And we could find in the statistics area, we didn't define statistics with that one. Well, that's unfortunate. I'll pull up another one. I think this SIR model here we did. Okay, so we could go down, and here's some statistics associated with this. And these are examples of expressions. They calculate values. There are these formulas like you use in Excel. This cell is that cell minus this other cell. This cell is that cell divided by this different cell. That's the sort of thing we're putting here with expressions. They're descriptions of how to calculate a value. And all these reduce to a thing like a number, or a reference to an object, or a reference to a string, or what have you. So these are expressions. We talked about them yesterday. We talked about the meaning of dot. And when you have this sort of function call called a method call, and that's all well and good. Very important, and those are a large fraction of what you put into AnyLogic models. You put in these expressions lots of places, but almost as common as them. And something we've seen in virtually every model that we've built, ladies and gentlemen, has been also the presence of these things called statements. And these are associated with these actions we perform at different times. So, for example, here's a statement. Color equals green. It's a command. It's saying, do this. It's not merely calculating some value and using the value. Instead, that's beside the point, the value. What it's actually doing is it's changing something. It's assigning to this color variable. It's making it be green. Similarly, for each of these other components. So when you're creating things in Java, what you're creating is a mixture of, on the one hand, expressions, these things that calculate values. 10 is an expression. It's a literal value. And, we have mixtures of those together with, so this is another value, another expression there, together with these things called statements. These things that tell it to perform an action. And the statements are marked by semicolons. It's kind of like seeing in English an exclamation point. It's It's an imperative. Do this. Or, wow, this happened. Here it's saying do this. Okay, so we have these statements, and they're woven in. And sometimes they're very simple, like this, color equals red. But then sometimes they're more complex. So, for example, in this open population model, we actually strung together a bunch of statements. So we went, for example, and associated with person. Well, for this immigration event, for example, here is a place we strung together some statements. Here we have an expression, the rate. This is determining a value, right? So there's no semicolon needed. We're just calculating a value. But then down in the action, that's statements. What it's expecting in actions, entry actions, exit actions, actions associated with a transition, actions associated with an event. It's expecting a statement. The first calls this thing and returns a value. Immigrant. And second of all, it applies to network. Those are two statements. You see the semicolons. And we're going to talk about statements today, the different forms that they take. This is one form that they can take. They can just have an expression here, like the call of a method, of a function. And that could be a whole statement just by itself. And in this case, it's saying this call here is not returning anything. It's doing something. It's applying a network. It's knitting in this new immigrant in the network. That's what it's doing. But we're going to see there's a variety of types of statements. And coming out of it today, I'm going to show you some code that we didn't even write. We'll take a look at some code we did write and try to make sense of it, but we'll see some code we didn't write, but that AnyLogic automatically produces. And we'll see there's no magic there. It makes sense, okay, what it's doing. So let's go take a look at some statements. Can anyone in here, before we begin, can anyone mention any of the statement types we've seen? Think about a statement. Sorry?
That's not a statement, that's an action.
So get, there are times we call things like get connections number or something like that, but that's actually a method call. But there's some statements that have done things before where we've actually used it to perform an action. Do you remember, like, if you have to loop over things? What was that called? A for statement. Yeah, it was a for statement. That for statement is an example of a more complex statement. It sort of says, over each person in say, some collection, say a population, do this certain thing. That's one common form of it. There's other statements like if statements. I'm not sure what we saw one, but we didn't really comment much on it. In other forms of statements yet. So we're going to go through a sort of guided tour of various types of Java statements. Okay. So let's talk about these. So one thing I want to introduce, and I haven't done so, is you'll see sometimes in amidst statements you'll see things that are actually comments. So things like this. Okay, we'll now knit this new immigrant into the network. That's what's called a comment. AnyLogic doesn't care about this thing, but it's very important for us as humans to be able to have these nice comments. They orient us as to what's going on at a given point. And so we'll often put these things in there. There's two forms they can take. That's one of them. A second form they could take is like this. It goes like this and like that. The difference is this first one only applies for that line. So it just says the rest of the line is one. So if we start typing here, it's not part of the comment. This other form, everything following it until you have one of these is part of it. So you could have several lines, and they're all part of the comment, as indicated by the green. Okay? So those are comments. Comments get ignored as far as AnyLogic and Java is concerned, but they're very important for describing intentions. Okay. Yes, question.
Can you do Javadoc with AnyLogic? Can you put Javadoc comments in and have them rendered?
That's a very good question. I'm trying to think about this. I have conflicting memories about that. I remember doing some things related to this several years ago. It's not a feature I use a lot, but it's a very real.
For a big program, right?
Absolutely, it could be very, very useful. What we use more commonly is generating the documentation for AnyLogic models, and that's very, very useful. But the JavaDoc side we haven't used in recent years. Basically, JavaDoc would provide information on the various pieces of your model, particularly the functions, for example. What it would allow you to describe their function, their job, their intention behind them, and would allow you to insert information, for example, on what they require as an argument or what they return. So I don't think I have a good answer to that right now, but we could easily find out, and it may have changed for AnyLogic 7.
Okay, and I have a quick follow-up question.
Yep.
Do you ever use the description aspect of AnyLogic, like down below?
Oh, yeah, we do that some. That's very useful. Thank you for highlighting that. So it's noting here that you can put actually metadata here. You can describe what this is, what the significance of it, what's its intention, what is being done here. Perhaps the source of values used here, that we're making an assumption first explained in this paper, or first, previously applied by this other model, or what have you. It allows you to describe something about the kind of context and motivation of what you've done up here. And that's a very useful little feature, because it allows you to bundle together the metadata, the thing about this, describing it together with the thing being described, rather than a separate document. So it's a very useful little bit, and that can appear in the model documentation that's generated automatically, I believe. Okay, so let's talk about Java statements. Java expressions, calculated things. Java statements do something. They make a change to something. Statements are commands, for example, that change the value of a variable. Or they'll return a variable from a function. They'll say, return this. And the function will say, yes, I'll return that value from the function. That will be the value of that function. They can call a method. We saw that earlier. So, for example, this calls a method here. It's calling off to it. That's great. This return a value, we saw that in another case with this open population model down in persons, in a thing that take the necessary time to explain well. Here's get age. It's a function, and what it returns is the current time minus their birth time. If they were born at time 30 and it's now time 40, they're 10 years old. And that's what its job is. This is called a return statement. It gives back a value. So when people call get age, this is the value they get back. You just take the current time and you subtract for it the birth time, which is one of the parameters here. Okay, so that's a return statement, for example. Another thing that they could do is perform a sequence of statements a certain number of times. You've seen that with a for loop going through it, one after the other. And it could do one set of things or a different set of things based on some condition. Okay, so when AnyLogic is seeking action code, when it's seeking code to do something, like we enter the pregnant state, we exit it, we go to this death state. All these things where it's asking for actions, it's actually asking for statements. It's not looking for a value. It's looking to do something. When this person goes here, you trigger something. Something gets done. So you'll find these things scattered throughout AnyLogic. You'll find them within these visual properties. You will also find it, and you'll find it in states. You'll find it in transitions here, the action here, the action here. But you'll also find it, for example, associated with broad classes of things in general. So, for example, main has an on startup area. So when it starts, you do something. It's looking for statements. When it's destroyed, you do something. When it's about to go away, you close your database. You save files out, what have you. Similarly, in person, You can do things when a person starts. You get some things ready for them when they're destroyed, on arrival, to a target location, etc. There's lots of places in AnyLogic we're asked to insert actions. And those actions are statements. Okay? Okay, so let's continue to talk about statements here. Here are some common Java statements that we're going to be going through. If, for, while. We've seen these ones for like return. I'm going to emphasize that a little bit. We'll talk a little bit about this try, catch, finally, and associated throw. And we'll talk about assignment, how you can call off the functions. And finally, you can have a composite statement block. So in some places you'll see, and this is very common, I have a little example of it earlier. You'll see, for example, there's these curly brackets, do, and then it goes down to here, an end curly bracket. This curly bracket. That's called a compound statement. It means you can put a whole bunch of statements in there and it'll all get done. You could put one statement under it, or you could put one of these compound statements. That's just one statement. It's just a bunch of statements inside of it. And that's useful. Here's another one up here. These are curly braces. They're kind of it's not just a parentheses. It's not a square bracket. There's parentheses, there's square brackets, and then separate from that, there's this thing that looks like that. That's called a bracket. This is called parenthesis. This is a square bracket. This is a curly brace. I'm sorry, curly brace. We don't have great names for things, but that's pretty common. Some people call it curly bracket. Yeah.
What happens if you've got, say, three statements, or three actions you want?
Yeah.
You've got three statements underneath each other.
Yeah.
Why would you put them in curly brackets?
Because two good reasons. Let's take a look at an if statement. We'll get started in our statements, and this will be a prime case where this is needed. Take an if statement. Okay? So you have if some condition. If this dot sex equals and doubles equals male, equals person dot male. We've seen that before, right? Equals sex dot male. If my sex is male, then I will do something, right? Some people would say we'll do something stupid, but I'm more likely to do something stupid or something. So here with the consequence. We may want to say several things. So if I'm male, I want to do this, and this. Now, it only allows us to put a single statement under it. Okay, let's actually do this. Let's type this out. In an example here. So here's person. This is our open population, and I don't expect you folks to follow along here. But within person, maybe I'll go down and I will go to their state chart, and I will say, if here, if okay, I'm just thinking about a plausible if here. Okay, if this is not going to be that great. If this dot sex equals sex dot male. If my sex is male, I'm in trouble. Okay, so here, suppose I wanted to do several things. I wanted to print out, I'm in trouble. Something is wrong, right? Something is wrong here, and then suppose I want to now, beep or something like that. I don't know what else I'd do. I'd call up a window and I'd put something out to a file that says, ignore this data, something's wrong with this model. There's better ways to do this, but the general point is, if we have several things we want to do here, if we just put them under here directly, it's actually the meaning is going to be like this. It's not under the if. It will automatically be executing this. Only this first one will be conditionally executed. It's only if this condition is true, then it will do this. In any case, it will continue on and do that.
So can I just check?
Yeah.
That's indented. Indenting is actually an important thing to do?
Indenting is important for people. Java ignores it.
Okay.
It's very different from Python, where it pays attention to indenting. As far as Java is concerned, it doesn't care how you indent it. The question is this actually a statement within it? And you're only allowed to have one thing under here.
Right.
And one statement under here. And you could create a compound statement like this that would go under here because it allows you to do multiple things in it. That's one reason. The other reason is that you could actually declare a variable in here. You could say, person grandmother. My grandmother is my this.mother.mother. It's my mother's mother. My mother's mother. Think of the dot as kind of like an apostrophe S. So this is my mother, and this is her mother, the mother of my mother. Okay, so here we can actually declare variables inside these compound statements, and then we could use them, and we could say, trace ln, my grandmother is so-and-so, and it would print it out. And grandmother would not be visible from outside here. So it's a nice little way I can kind of temporarily define something that's a nice little name for my grandmother, and then it will no longer be in use. So there's two big uses for those sort of compound statements. I don't know if that's helpful at all. But, okay, so an if statement, what is an if statement doing? It comes in several different forms, but fundamentally it's determining should we perform an action or not, depending on a condition. Depending on a condition, should we perform an action or not? And if this condition is true, what is this thing? Who can tell me from yesterday, what is this thing that stands before us? So yeah, it's an expression that evaluates the Boolean. It's an expression whose value is a Boolean. When this gets evaluated, the formula gets calculated. What comes out of it is a true or false. It's either true or it's false. Either your sex is male or it's not male. And so if takes a Boolean, something that returns a Boolean, and if it's true, it does this thing beneath it. If it's false, it will not do this so-called consequent. We call this thing the consequent, the thing that comes about if it's true, okay? And here we go. It's called the consequent. Now, you can have it in this form. If I'm male, then I do this. Or you could have it, if I'm male, do this, otherwise do that. So you have an else. And sometimes you see these strung together quite extensively. Now, for a dichotomous thing like sex, you don't need to. But, you could have something like, if this dot, get age here. If this dot get age, is less than 10, well, okay, and that would be weird. This dot get age is less than 15, do a certain thing, else if this dot get age, this is not a particularly nice way of doing it, I'll show you a better way, is less than 25, then do something. It'll only do this if someone's between 15 and 25. Else if you could string these together on an ongoing basis. Else if this dot get age is less than 30, we could do this other thing. I don't like doing it, and when it's a long list, there's better ways to do it. But the general idea is you can have these else if to handle these different cases. If this is true, we do this. If it's not true, we go and consider whether this is true. If so, we do whatever is in here. If not, we go on and see this. If so, we do what's in here. Does that make sense? Okay. And the most simple form of having two options is if you were to have this. Else a certain thing, like that. Does that make sense?
Yes, it's like the system dynamics, if then else, except you don't have to write the same thing.
Yeah, that's right. You always have to write this top one. You could have to write this other. You could write the other one if you want to. Now, this is good. I would say if we just did what I did here, if we had something like this, I don't like what this is doing, and why not? If I look at this, I think it's unnecessarily confusing because it keeps on calling this .getAge. Not only is that inefficient, but visually it's not obvious immediately. These are all the same thing. I gotta call. it's all each time it's calling this .getAge. So it's using the same thing again and again. It'd be much nicer if I just said double age, current age equals this .getAge. I just gave a nice little name for my current age, and then I just keep on reusing this. I use a nice name for it instead of having to keep calling this complicated thing. I just use current age there, and it makes it easier to understand. Okay, so it's a nice little brief thing, even quicker, but arguably it's arguable whether it be as good. We just need to say age, and we could just say if age less than 15, if age less than 25, if age less than 30. Current kind of to me connotes it's my age right now. Yeah.
That is fleeting is personal grammar?
Yeah, it's fleeting in the sense that right after this place it will no longer be visible. How do I know that? You want to see something? You folks are mature enough to see this? Okay, yeah. Control J, this is where it places me. This is the code that AnyLogic has produced. Notice that this is all inside of, what is this? It's all inside of a compound statement. So it actually has pasted this in, and this is as fleeting as that. It just exists there for that brief moment where it's actually calculating this, and then it disappears. So it's actually putting it into a statement. This is all code that AnyLogic generates behind the scenes. You don't have to look at that much. Again, I look at that maybe twice a year, maybe 3 times a year, but occasionally it's useful. Okay, so that's an if statement. An if statement is really handy if you want to do something different based on some condition. We saw a different form where you want to have a different formula. If this is true, use this formula, otherwise that one. That question mark. If I'm female, then question mark. If so, use this value, otherwise use that value. This is if I want to do something different. Then based on this condition, do it here, otherwise do it there. Does that make sense? People kind of comfortable with that? This if statement? Okay, and you'll see these things quite a bit. So here, this is in an AnyLogic example model. If the elephant is thirsty and the altitude of their current location is less than 0, which I happen to know means that there's water there, then they should drink. They should drink from the water. If the vegetation is greater than a certain amount, they're going to decrease that vegetation. This is not a particularly nice if statement because it's a little bit unnecessarily complicated. This is a little detail that the reader shouldn't have to know about, that if the altitude is less than 0, that implies there's water. Really, it should say if thirsty and, water is water, the current location, then do this. So this is not well named, but it's an if statement that considers 2 things. Does anyone remember what that and side means from yesterday? Double and? It means, if this is true and this certain thing is true. If they're thirsty and this thing. If either one is not true, they're not going to drink. You can bring an elephant to drink. You can bring an elephant to water, but you can't make them drink, right? So the elephant has to be thirsty and there has to be water available. Okay? that make sense? Okay. So those are examples of if statements. Oh, this is another terrible one. Oh, man. This is an if statement, but it's an undignified if statement. It's an if statement unworthy of the name. It's an if statement that's abusive. It's a bad example of an if statement, and I'd like to show you this bad example. Why is it a bad example? Because it's checking two logical things. It's checking, is there water here? And are we within bounds? But it does so in an obfuscatory manner. It's so complicated that it obscures what it really means. You stare at that and say, what the heck? What is 500? What is 0? Basically what it's doing is it's checking, are we within bounds? Or are we at a place with water? And ladies and gentlemen, that's something which can be denoted much more cleanly by calling off to two functions. Is this within bounds? And am I at water? And if so, it'll be cleaner. So that's obfuscatory. Okay. Okay, I'd like to discuss now any questions on if before I go on to for. Okay, let's go on to for. For statements come in a variety of forms also. We saw if came in a variety of forms. If with just the consequent, if else with a consequent and alternative, and you could string them together. For statements iterate. They perform a loop known in my youth incorrectly as a pool. They iterate. They repeatedly execute some statement many times, typically giving a name for each successive thing. So, they come in two most common varieties, and I show them here. They stand before you, and I'd like you to meet them. So, the first of them is this case where we count successive values from one number to another number. This is very common. You go, for example, from 0 to 100. This is counting up 100 different numbers. 0, 1, 2, 3, 4, 5, so on up to 99. And for each of them, it's executing the statement. Maybe the statement prints out I. Maybe it looks up person number I in the population and prints out their name. Maybe it records the data for each person in the population, person number I in the population, to a database. Maybe it prints it out to an Excel file. Here, for each value of I successively, I 0, I will be equal to 0, will execute the statement. I equal 1, will execute the statement. I equal 2, execute the statement successively. This form of loop is exceptionally common. The basic deal, it looks complicated, but it's basically a little pattern. It's a little idiom that you look at. So basically, I is initialized to 0. It starts at 0. It's an idiom. It's a typical thing that you have less than this. And what that means is it will stop just short of this 100. It'll stop in this case because it's an integer. It'll stop at 99. That'll be the biggest value. And there'll be 100 of them. But because we're counting from 0, we don't go all the way up to 100. Think of it. If you were counting, if you only wanted 1, it would go from 0 and that's it. It wouldn't go up to 1. If you wanted 2 of them, it would go 0, 1. It wouldn't go up to 2. So here we go up, we go 0, 1, 2, so on up to 99. There'll be 100 of those, including 0. And for each of them, we'll execute this statement. And we'll just do this statement. Sometimes the statement doesn't even depend on I. It's just doing it again and again and again and again. It's doing something, again, because it requires repeating. Okay, so this is one form of statement. Are people okay with that?
Yes and no, I understand it. But
yeah.
My logic is disturbed by the fact that we've got the semicolon inside before the...
Indeed. And there's also this plus plus. So what's happening is, I should have completed the explanation. It starts with I equals 0. Yeah. It tests, okay, is I, so at the beginning of every iteration it tests, is I less than 100? Is 0 less than 100? Yeah, it is, okay. So it's going to perform the statement, and then it's going to increment it. In other words, I will go from 0 to 1. And then it'll test, is I less than 100? Yes, it is. If so, we'll perform the statement, and then it will increment I. I will go from 1 to 2. And it will test, okay, is 2 less than 100? Yes. Yeah, okay.
It's just for me, my logic says the semicolon should be outside the bracket.
Yeah, the semicolon here is, you should think of it as kind of not the same meaning of semicolon as at the end of a statement. Okay, I hate to say it, but there's only so many keys on the keyboard, and maybe they should have made it an @ sign, or they should have made it a star, or
It's not the semicolon we're used to.
an exclamation. Just about a lot of these are actually overloaded for other things too. A star means multiplication. An exclamation point means not.
Okay.
Yeah, so maybe they should have made it an ampersand. No, a backwards tick or something. But yeah, it's a different form of semicolon. You just got to recognize this as an idiom. It's just, it's kind of like a phrase, you know, you know, if we say meantime, it doesn't mean, you know, it's nasty time or something. It's a single phrase that has its own distinct meaning. This has its own distinct meaning. Is that okay?
Yeah.
Okay, the other form we've seen is this. Where do we see this?
Bad.
Yeah, we saw it with bats, we saw it with people. When you're inserting them in a histogram, or data into a histogram, we said for person P in population, do this. We said for bat, lowercase bat, capital bat, lowercase bat, in bats, do this thing. And this thing typically, the statement typically depends on the thing being iterated over. It depends on the bat. Depends on the person. So it goes over for each element of this collection, it names them, in this case, A in turn, or it names them bat in turn, or it names them person in turn. For person, call it P in population. We'll call each person successively P and let you do something with them. Maybe print out their name, or maybe store them information to a database, or maybe check whether or not they're alive, or what have you. Does that make sense? No.
Is that a preferred way over iterator? Do you even use iterator anymore?
No. It used to be in Java very common. Back in the day, 20 years ago, when Java was first introduced. It's very unusual now to see it. I do see it occasionally from beginning Java programmers, which include many of my students. I don't mean grad students so much as my undergrads that I teach, software engineering, but it is a increasingly rare thing to see. But I do encounter it as an educator.
How did that statement know we got 1 at a time?
Because I++ means actually to increment it by 1, by a single value.
Okay. What if you wanted to go, say, 5 at a time?
You do I plus equals 5. Or you could say I equals I plus 5. That'll be another way. But the shorter, the briefer way, remember we talked yesterday, there were some of these little sort of concise operators like I times equals 3, meaning I equals I times 3, or I plus equals 5, then it will increase it by 5. And it's kind of convenient because you kind of know, oh, we're just talking about increasing I by 5. There's no other variable involved. If you say I equals I plus 5, you got to look on both sides. Is it the same variable? It just takes more time.
I plus 5.
It's our I plus equals 5? Right. And that means we're taking I plus 5 and we're assigning it to I. We're making I now the previous value of I plus 5. Okay? Yeah. So you could say I plus equals 5. And that's also pretty common. Say I plus equals 2. It goes up by 2s. I plus equals 10. Up by 10s. Yeah. Is that helpful?
Yep.
Okay, that's it. I'd like to show you something. I'd like to show you something that I hope won't scare you. But which it's about time we learn to take with comfort. Okay? Okay, so let's go to main and let's go to the population. And I don't want you to fear Java. And let's go take one of these things. The mean number of connections over the population. Do you remember this? Here, we're taking the average over this measure for each person item. Remember that? Each person item, we're going to compute their connections, the number of connections they have, how many people are there connected, and we're doing it without condition. We're not restricting it to any subset of the population. And we're going to take the average over that, right? Ladies and gentlemen, let me show you that often the code that AnyLogic produces is nothing to fear. I'm going to press Control J here. Notice my cursor's in the middle of this. I'm going to press Control J. I'm going to look beneath the hood to what this translates. And this is what it translates to. Can anyone help me understand what is going on here? You have all the requisite pieces. Don't be thrown off by the underbars. Those are just part of the name. It's just a strange name which happens to use an underbar. But what's going on here? Can anyone translate for me what's going on? What is this doing, CNT? Count, yeah. You know, I'm actually thinking, I will do this, but before we do that, I'm going to do an even simpler one, and we'll work up to the one we were just seeing. The one we were just seeing is something that we could figure out, but it's this one here that I want to focus on first. It's this count. So remember this one? We're counting the numbers that match this criteria, right? Okay, so let's go take a look at that, and we'll work up towards the last one. Here we go. Okay, so what's going on here? So what is this doing? It's getting a value. It's creating a variable and it's giving it a value of 0. Nice little value of 0. And then what is this for loop doing? So what does a for statement of this sort do? It goes through every person in the population. It calls them what? Item. And then here it's saying, okay, is this thing true or false? Is this Boolean? It's true or it's false. And where's it getting that from? It's getting it from what he told it. And if it is true, then do what?
Increase the value.
By 1, and then return the value. So suppose in the whole population, it goes through each and every item, and suppose it's only one of them for which this is true. Value's going to start at 0, it will be going through, not finding any, not finding any, not finding. Finally, and each of those times it's not finding, T will be false, because this thing will be false. It will not be infective. Then finally it's going to, and therefore it won't increase the value here. T value will stay at 0, stay at 0, stay at 0, while T is false. And then finally it will get to one where this is true, it's true, and then what will value become? It will go from 0 to 1. And maybe that's the only one it finds, and it's going to return what? 1. Because there's one thing for which this is true. Suppose there were 2 of them that were true. It would start at 0. It would find it would go through a lot where it can't find any for whom this is infective, calling each person item. It'll finally find one where it's true. It'll go from 0 to 1. Be going more, looking. Finds another one for which this is true. It'll increase it from 1 to 2. And then it will return true. So this basically counts the number of people for whom this thing is true. Does that make sense? Based on what we've learned about how a for loop works and an if statement. And this is the code behind statistics. This is how statistics work with respect to count. Now, having done that, we're going to take this one step further and look at the one we started with there. So we're going to go down here, we're going to look at an average. Okay, here's an average. We're going to go back to this one. This one that, and we're going to figure out its little pieces. Okay, so can anyone help me understand what's going on here? So here we have CNT. Can you guess what that means? Count. Okay, and so here we're going to go through and we have some value, which is, and we'll see what that is. It starts at 0. It goes through each person in the population. What happens when it gets to each person? It automatically increases the count. We're not just counting people for whom something is true. We're just automatically increasing the count. In other words, we're counting at the end of this. Guess what count will hold? It will hold the number of people in the whole population, right? Okay. And what's value being increased by? Well, whatever we told it. Remember, we told it perform the average over this thing, item.connections number. So what is it doing here? Main.java, what is it doing here? It's increasing value by this thing we asked it to compute the average over, right? Now, why would it be doing that? Well, if it totals it up over the whole population and it has the number of people in the population, what can it do then? It can divide one by the other, right? Okay, if we total up the income across the whole population, we divide it by the number of people, we get per capita income, the mean income over the population. And that's what that last line does. But it does it with a twist because it's guarding against the case where count is 0. It's got to deal with this case. Well, maybe there was no one. What do we do then? If count is greater than 0, it just divides value by count. If it's not greater than 0, we just return 0. Now, this code is ugly for me to look at. I don't like looking at it because it's got this thing sitting way over here. It's got these weird underlines. It doesn't have particularly evocative names. But I can kind of understand it, and I hope you don't feel scared by it, too. I mean, this is how statistics work. I mean, when we type statistics in, that is how they do their job behind the scenes. We don't have to worry about it much, but there's no mystery here in the sense that these statistics, it's kind of producing code that counts them in kind of the obvious way. I essentially never look at that, but it's useful to know that there's nothing scary there once you understand like how a for works and an if works and how a variable, declaring a variable works and what this plus means. Yeah?
What was the plus equals again?
Plus equals would mean, so I'm going to write it up here. Suppose I said I plus equals 5. What it would mean is exactly, I'll put a semicolon here. That's a statement, and this is a so-called expression statement. It's the expression that happens to be a statement. And what this means is I equals I plus 5. It just increases I by 5. Yeah. Does that make sense? Yeah. Yeah. And so we saw that just then. It's a great question, Chris, because we saw it right here. We saw it right here. Value plus equals that. We're just increasing value successively by this thing we want to take the average over. Does that make sense? Okay. Yeah, question.
Just curious, why did they use underlines in front of their variable?
It's a convention that you'll see occasionally used to indicate sort of a secret internal variable they don't want particularly other people to use or to know about or to sort of get confused with.
So it's just a convention.
It's a convention. It makes it less likely that somewhere in here, imagine if you did something like in here, you had something called CNT or something like that. They don't want to get them confused with their thing, so they want to make it a kind of weird name that you won't guess, but still make it kind of obvious. And so putting an underbar would be very strange. If we name something with an underbar in front of it, it would be like calling a child root or something. You know, it would be a very strange, unusual name. And so it makes it less common. It makes it less likely to clash with your own names. Yeah.
So isn't there some value plus equal?
Uh-huh.
Isn't there something?
No, value plus equal this thing?
Oh, that's the underline.
Because this is an important part. it doesn't care about white space. It doesn't care this is on the next line. It just happily presses it until it gets to the semicolon. Semicolon at the end of it. It just keeps on looking forward, getting more. So it's value plus equals item.getConnections number. And then the semicolon finishes the statement. I don't like to look at code like this. Code like this is, I think it's ugly, and because it's ugly, it's hard to understand. It's distracting, but it's understandable. You can look at it and kind of puzzle it through and say, oh yeah, that kind of makes sense what it's doing. Now, I hate to tell you this, folks. Hate to tell you this, but very rarely, and this is again something that might happen in all my teaching. It happens maybe a few times a year. I go around teaching people things, and people ask me interesting questions, and I go and I sometimes need to answer questions which I don't know the answer to, and I want to find out the answer here. So I'm going to go here and take a look at one of our models. Let's say the open population model here, and I'm going to go look at population here. And do you remember I said that thing about self? Like, you could say if you wanted their income to depend on their sex, you could refer to sex dot, self dot sex. How did I know about that? Well, I couldn't find it anywhere in the manual. I figured there might be a way. Let me take a sneak peek. What's going on here? Control J. Oh, look at that. Oh, there's a thing called self. Oh, okay. Okay, so it's called self, eh? Okay, so calculated sex there. Okay. So it calculates them in the order that it uses. Okay, so fine. So if I wanted to calculate income, I could just refer to self.sex, and that's how I'd find out what the sex of this person is. That's occasional. I don't like doing that, but if I can't find any documentation and I'd like to check it with them, they're not going to change this thing. But occasionally, it's useful to kind of peek at what's going on to figure out, how can I do this, or what's really happening? Why am I getting a weird message here? You can go kind of peek, and you could say, oh, it's called self. Okay. So if I had an income thing here, I could refer to self.sex, and have the income depend. I don't like it, but it happens. Okay? Okay. So let's continue on a little bit. Here's a for loop. Sometimes for loops are nested in each other. One is inside the other. And what that means is if you have like 4x equals 0, x less than 100, x plus plus on the outside, on the upper, the higher level, and then inside of it, for y equals 0, y is less than 100, y plus plus. It means it's going to take every possible combination of x and y. X equals 0, y equals 0, x equals 0, y equals 1, x equals 0, y equals 2, x equals 0, y equals 3, all the way up to 99. And then x equals 1, y equals 0, x equals 1, y equals 1, x equals 1, y equals 2. And you get the picture. It takes all possible combinations of them. And that's exactly what it's doing in this loop. It's taking all possible combinations of angle and of distance and doing some calculations. And I don't like to look at this code. I think it's code which has lots of bad practices in it, but it's a common thing. You have one loop inside of another, and it's very powerful. You can do all possible combinations of age and sex, for example, or what have you. Okay, so I'm just looking here. Right. Okay. Another thing that we'll find is a while loop. This is less common than for. For is sort of quite a bit more common, but a while is kind of similar. There's two forms of this. One is the test at the beginning, and one is the test at the end. This is one with a test at the end. This is an AnyLogic code for an AnyLogic model. So here, do while. So you do this thing once automatically, and then you continue on doing it as long as this condition is true, this horrible condition. I feel embarrassed showing it to you. This condition checks if we're within bounds and if we're near water. And that's how it should be written. It should call two functions. Is within bounds and is at water. But instead it's god-awful horrible. Don't write code like that. Create functions. We'll talk about those next time. We'll talk about those tomorrow. They'll simplify your life. They'll simplify your ability to understand your model, simplify others' ability to understand your model. They'll let you modify it one place instead of many places when you have to make a change. Okay, but this is a do-while loop. It does this while this thing is true. It does it once. If this thing is true, it'll continue on, do it again. If this thing is true, it'll continue on again. If this thing is true, continue on yet again. It'll do it as long as this thing is true there. Does that make sense? Okay. What's that? Well, yeah, it's Fortran had its own aesthetics, and I've never been a fan of them. In any case, another form of while has the while at the top. You say, while this thing is true, do this thing. And there, the thing to do may never be executed. If the thing at the top is false, it will never execute. Thing at the top is the predicate that it's testing is true. It'll be executed once, and then it will see if it's true again. Execute it again. We don't see these nearly as commonly in AnyLogic code, but occasionally you do, and this is an example in a little model that AnyLogic provided. Okay. I don't know how much I want to go into this because I really want to focus things on things you're likely to encounter. There is another thing called the switch statement. Switch basically handles a bunch of different cases. It will handle a bunch of different enum values. If this is Maori, then do this. If this is Caucasian, if this person is Maori, do this. If the person is Caucasian, do that. If the person is ATSI, do this. If the person is Asian Pacific Islander, do this other thing. It can handle a whole bunch of connections. And the way you say it, you'd say it something like this. I'll just write it. So this is this open population, and actually I think, is this the one we have? Yes, we have ethnicity within each person, right? And so one thing we could do is we could have a something which, for example, prints out their ethnicity or returns their ethnicity as a string. Okay. So we'll add a little function. It'll say get ethnicity as string or something like that. I would call it str ethnicity, but it doesn't take anything. It returns a string, and this will be the body of the code. Something like this: switch. There's better ways to do this, somewhat better, that are more advanced, but switch this dot ethnicity, and I'll say case. Each case, as a case, we'll say case ethnicity. Hey, I thought there was a thing called ethnicity. Here. I thought there was an option list. Yeah, option list. It's called ethnicity. Yes. Okay. So what's this thing's problem? Okay. It should be able to complete that. Case ethnicity dot Caucasian. If they're Caucasian, return white or something like that. And case ethnicity dot Asian, return Asian Pacific Islander. This allows you to sort of have your own sort of custom names for things. Case ethnicity dot ATSI. In that case, return the full definition of ATSI, what have you. Is that Australian territories and states, indigenous? On Torres Straits Islanders. So Aboriginal and Torres Straits. cylinders. Okay, thanks. So here we could handle each of these cases, and this is kind of like an if, but you don't have to separately test each thing. You could just list out the various possibilities. Ethnicity First Nations, and you could say, return North American Indian, was sometimes used, or Native American. Sorry, Native American. Okay, and so on. So this is what's called a switch statement, and basically it consists of you say switch on that. So in other words, based on what this is, for each of these cases, do something different. So return this, return that. And this is a statement. So for each of these cases, it does something. Now, normally, if this didn't have return, if it just had an assignment or something, you'd actually have to write break after it, which means it won't drop down to the next one, so it'll go after it. In this case, it's return, so it'll just leave the whole function. It'll just leave immediately. But as a general rule, you put breaks after these so that this one doesn't fall down into this one. It sounds strange, but it's something that occurs unless you tell it not to. So you put breaks after them by default. In this case, you don't have to because it's return. You're leaving the function. It's not going to continue on. But if this was doing something different, you need a break. Anyway, that's switch. You rarely encounter it, but sometimes it's useful. Yeah.
So an option list is an enum?
An option list is an enum, yeah. And there's better ways of doing this with enum, and there's a thing called enum map, and you could use that. But this is a powerful way of doing it too. So, for example, there's a switch case that I have some my code I provided to you. Based on the network file type, is it a PIEC file? Is it a connectivity matrix? Okay, that's good. Composite statements we talked about. Variable declarations. We have seen them all throughout. I don't know that I have to talk about them very more. You declare a variable, you give it a value, an initial value, and that's it. And then you can refer to it very nicely using like X instead of calling getX. If you're going to have some long bunch of code and you want to refer to things like the column and the row, you just give an expression for them once, and then you can refer to them many times. You don't have to use the same darn thing every time. You just give a nice name for it, for that value. Whatever this returned, that's a nice value, 3 or 25 or whatever. That's called C, and then we keep on using it. It's much cleaner than sprinkling this expression in everywhere. Does that make sense? It's a matter of clean code, as we say. And then we can have things that are so-called expression statements. These are expressions. X equals X, whatever. That's an expression. It returns a value, but normally here we ignore the value. It's just we're doing something. Here we're updating this statement. So we put a semicolon after it's a statement now. It's a statement. It just does something. We're not actually using the interesting value. Okay? X plus equals 5. That's a statement. It does have a value. It does have a value. It's the value of it. If I'm not mistaken, yes, it's the value of it, the original value plus 5, but we're not using it. We're just throwing it away. The point of doing it is to increase it by 5. That's the whole goal. Okay. I don't know that it used to be we had to talk about this more. I don't think I'll trouble you with it. Suffice it to say that things sometimes go wrong in Java. You saw that today in a most embarrassing way. Bad things happen. And one of the ways they happen is this thing called an exception is thrown. It comes up and it says, I don't know what to do. I'm in trouble. Help me. And it gives you a bunch of information. And tomorrow, ladies and gentlemen, I'm going to provide you the core information you need to make sense of that information. So when it does something bad, when it does something when it's unhappy, you'll be able to figure out why. You'll be more likely to zero in on why it's unhappy. What is it unhappy about? You can learn to read it. Okay. This is the BAT model, and And this bat model, I thought, should work with this nice thing. And we looked it up more, and we're convinced it's an AnyLogic bug. But it did. It was an unhappy camper. Here we have these nice bats, and we changed this thing, and there we had. And notice what it says, exception. That means something bad has happened. But that's not where it ends its information. It actually tells you where the things went bad. If you start to reason through, you start to be able to read information out. If you look at this up front, you think it's gobbledygook. But it's not. It tells you it's something about the arrival time, not being a number, and it's telling you that it occurred somewhere in this move to. Okay, it's something to do with move to, and it's something to do with entering a state. And we can actually go look at the state, and it will say, oh, it has something to do with this guy here. Oh, okay. So that's actually what the particular statement that had the problem. Tomorrow we'll learn what this means. Right now, why are these things listed out in this weird order? There's logic to this. It actually, the ordering here tells you quite a bit about what's going on. It tells you what called what, called what, called what. But we're going to come to that tomorrow. Suffice it to say that exceptions are when things go wrong. We do what's called throwing an exception. And you can handle these. You can actually catch them, and you can do some things to handle them. You can fix things up if you want to. You can write a try around something. It tries it, and if an exception is thrown, it can catch it, and you can do something to fix up the situation. Hopefully you won't have to do that, but occasionally if you're calling off to other libraries or something, you may need to know about something like this, okay? So I have some code which uses this. So ladies and gentlemen, don't get too caught up in that. For AnyLogic, what do you really need to know? The three biggest things are these: if statements, for statements, and then these so-called composite blocks and these expressions like calls to functions, like this sort of thing down here. Here's a call to a function, call to a method, and this sort of thing where it's subtracting 10,000 for it. That's really what you need to know to do stuff in AnyLogic. If, for, maybe while occasionally, but you can, most things you can do with while, you can do with for, and in this thing with a composite statement block. You know, you can declare a variable. That's really important. You declare a nice little variable naming something, okay? It gives a nice little name to something, so you don't have to keep on referring to a long expression. You just refer once to that name, or you just refer to that name, and then you can keep on using it, okay? So those are the things you really need to know. Any questions? I know that the bus is here in just a few minutes, so are there any questions I can answer? Questions? Yeah. Yeah, I'm going to try to post them. I'm remiss. I did get all my slides up on the server today. I started uploading them all to YouTube, and I think they're there. I think I have to release them publicly now, but I got to go check on them. But the next order of business is getting all my slides up, including Java tutorials in a different place. So you can come look at those. Different folder, yeah. Other questions? Alan?
Yeah, I wonder how you handle constants in Java and AnyLogic. Do you have any particular conventions that you use for constants?
Yeah. Yeah. So I like to make constants as transparent as possible in the sense that you do not, so there's many good ways to handle constants, but there's some bad ways you don't want to handle constants, okay? And you can argue among which is the good ways is the best, but there's certain bad ways we don't want. And I'll tell you some bad ways we don't want. I could show them to you very graphically. It's things like this and this, where we have these constants sprinkled in the code. Why don't we want that? Because, ladies and gentlemen, I mean, look at this. This is, oh gosh, Oh man, look at this. Here's, you got these 99s and so on, and you know, at other places you might have 500 and then 100 here. Look at this. You've got a 10 here, okay, 1,000 here, and you don't know which of them is logically linked to another. You don't know what this 500, does it relate to that one? Are these the same 500 in the sense of what they mean, or are they a different 500? The same 0. You have 100 here. Is that because it's 500 divided by 5, or is it some other reason? The thing is, if you put constants in your code as such, the meaning of them, their origin, their provenance, what they really signify is lost. So the thing not to do is to sprinkle them throughout your code. Why? Because then if you ever have to change it, you have to go all throughout your code and find them. And you might miss some because you're changing the hundreds to 200s systematically. Fair enough. You do find, Control F. You can find all the hundreds in your code. This is a useful thing to know about, folks. You do Control F, and I can find anywhere in my model. It has nothing to do with looking at the code. I can find anywhere 100 takes place in my code. Okay, there's a 100 here, for example. I can go search for 100, but how if I forget? I put 99 somewhere else because it's 100 minus 1. It's logically linked to 100, but it's not the same. I'm not going to find that by searching for 100. So what you don't want to do is put numbers in your code like that. Now, I've been violating that in my teaching to you because I want to minimize the number of things the students have to do. But as a general rule, what you do is you give them names. Now, where do you put them in your code? What names do you give them? Where do those live? Now, that's a little bit more of a contentious issue. And you'll find several models I've shared with you that have different conventions. You can give them parameter names, and you keep them as parameters on the model. That allows them to be varied easily. And store them in main if they're constants. If they're constants across the entire population, some people say store them in main. Other people will say store them in the person just as what's called a static constant, a static final variable. And you could store them there. AnyLogic actually has in it, and any of you folks should please be encouraged to leave because I don't want to make you lose your bus. But if we go here and we go to a bat, let's go over here to our bats. Here we go. And or better yet, let's go to person and open population here. Here's our birth time. Here's our...
Is that the last one?
I think it's the last one. Yeah. I think that's right. 6:30? Yeah. You've got 7 minutes. So, but folks, if you have a variable here, we can declare a variable within this and call it some variable. Maybe it's my weight at birth or something like that, which might be a parameter, but I'm going to make it a variable here. I can do advanced, and I'm going to declare it a constant static thing. And I could give it, this is a bad example. Maybe it's, weeks of gestation or something like that, as a constant. It's something that's a constant across the population. And it might be, what's weeks of gestation? So 9 months times 4, so 39? Okay, so 39 weeks. So here, you notice it's indicated as a V with a dash. That indicates it's constant, and someone seeing that will know, oh, that's a constant, not just a normal variable. It's a constant variable. Static means that actually each person doesn't need a separate version of it. It's just there's one for the whole, across all people that share a single value. And that's a nice way to denote it.
Great. And you capitalize the name?
No. No, by Java conventions, this would be a lowercase. We capitalize class names.
Yeah.
We capitalize sometimes the names of things in enum values, although that can be contentious. I tend to do that. And we capitalize interface names. There's certain things we capitalize, but variable names we don't, and method names we don't capitalize. And that lets us distinguish them visually, what's what.
I just think in constants they're all caps.
Oh, that is an old C convention, and it's adopted by a lot of C++ programmers. You see it rarely in the Java world, but occasionally. There are cases where you'll see that. I think it's okay, but then what happens is you have to separate the words, you have to put it like an underbar, which sometimes flies if you use, this is using what's called camel case. You capitalize successive words within it, weeks of gestation, and it lets you read it. If they're all caps, you don't get that camel case, you have to use underbars. And then you've got a mixture of camel case and underbars in your project, and it's a little bit messy. But you can do it. I'm not totally opposed to that. But in AnyLogic, it does have this nice feature where visually you could see it's a constant. And if you look at some of the models which I provided you, like there's a gestational diabetes model, which was built, incidentally, by Dylan. Here, there's a gestational diabetes model, GDM, gestational diabetes version 3 here. And his is chock-a-block full of constants here. So you can go, oh, in fact, he did the uppercase. Look at that. Okay, here we go. And let's go to these. Boom. There we go. You could see them up here on the right-hand side. You could see they're systematically laid out, meters. This is before AnyLogic 7, grams, sex unspecified, starts as sexually mature, parent unknown, message birth, message get. So these are various messages which are sent, and these are all marked as constants. And notice he puts it in. It says constants for readability. So you can go down here to presentation, and you can drag in text here, and that allows you to put in these kind of nice little names here. Hey, come on, why isn't it? Hey, come on. Hello. Okay, there. Yeah, so this little text thing you can drag in there. Okay. Other questions? Okay, long day? I would agree. So anyway, well, tomorrow we're going to discuss something really exciting for me. It gets me highly animated. It's the use of defining functions and how functions work in call stacks. Yep, Dylan's announced the arrival or that it's bus time. So if you get out there right now, you should be able to catch a bus. Okay? Hey, thank you. Yep, see you tomorrow.